Hi, I'm Jared,
And I'm Nicole.
and this is Biomechanics.
Today we're going to discuss three important concepts that are at the foundation of biomechanics.
Exactly, Nicole. Today we're going to discuss the gait cycle, ground reaction forces, and the characteristics of viscoelastic structures.
So let's get started.
Walking. Probably what we think of as the simplest of tasks. We do it every day, whether it's walking to class, pacing the room as we talk on our cell phones, or just going out for a stroll to enjoy nature. But what happens when we walk? Did you know that walking is actually a complex process that can be broken down into several steps? Well, now you do, and it's called the gait cycle. Understanding normal gait helps achieve two important goals: prevention of injuries and improvement of running and walking efficiency. During the gait cycle, each leg alternates between stance phase, when the foot is contacting the ground, and swing phase, when the foot is not contacting the ground. You spend 60% of the gait cycle in stance phase and 40% in swing phase. Three primary components are involved in the gait cycle, the first being heel strike, followed by mid-stance, finalizing with toe off.
This movement pattern is described as a heel-toe transition. When a person walks, we should see some form of heel strike terminating in toe off. Abnormal patterns of movements would include the person who walks with a flat-footed gait, where they tend to lift the whole foot up following a heel strike.
Here is a heel strike, which we then see her carry through to toe off.
Something to know is the difference between stride and step. Stride is the difference between successive initial contacts of the same foot, whereas step is the distance from initial contact of one foot to initial contact of the opposite foot.
So to demonstrate, the difference between a stride and a step would be, if I want to take a step, I would go from one foot to the opposite. And to complete making another step and completing the stride, I would go all the way back to the beginning foot. When looking at the gait cycle, it's also important to note the difference between double support and single support. Double support is the time you spend weight bearing on 2 feet, and single support is the time you spend weight bearing on 1 foot.
So now that you understand the gait cycle, let's talk a little bit about ground reaction forces.
Ground reaction forces are the equal and opposite force the floor exerts on the body during stance.
There are many reasons why we want to understand ground reaction forces, some of them being biofeedback training and the various info we can gather that will indicate whether someone is a rear foot striker or a mid foot striker.
But why would we want to know that?
Excellent question, Jared. If someone is a rear foot striker, they are more likely to injure bone, and mid-foot strikers are more likely to injure soft tissue. But how are ground reaction forces measured?
Well, Nicole, ground reaction forces are measured using a force plate. There are 3 types: anterior, posterior, medial, lateral, and vertical ground reaction forces, and they can be displayed graphically.
Looking at the graph, we can see how the different types are displayed.
The vertical GRF data has an impact peak caused by the initial heel strike and an active peak that results from the foot carrying through to toe off.
So if you're a mid-foot striker, do you still see the impact peak?
Maybe. Sometimes it's absent. Otherwise, it's very small.
The AP graph is interesting because it goes from negative to positive.
And it does this because in the anterior-posterior direction, we initially have a deceleration, and then, as we carry through to toe off, we begin to accelerate. We've covered the gait cycle and ground reaction forces. So what's next?
The characteristics of viscoelastic structures.
What?
Most soft tissues in the body are viscoelastic, and this means they have both viscous and elastic characteristics.
Purely elastic structures do not depend on the length of time that they are stretched. However, viscoelastic structures do.
In these structures, energy can be lost to heat rather quickly, so as the stretch is held, energy is lost.
This leads us to something called velocity dependence, which means that the faster you contract, the larger the force and the smaller the displacement.
And you can see this graphically here.
Following this same concept, we find that if we hold a viscoelastic structure at a constant length, we see that there is a reduction in force. And this is called load relaxation. And graphically, it looks like this. Along similar lines, if you stretch a viscoelastic structure with a constant force, you will get a slight increase in length of that structure, a sort of creeping in displacement, which is why this concept is called creep. And graphically, it looks like this. We really hope that you've enjoyed this video and that it helps you cement in some of the concepts that we've talked about today, like the gait cycle, ground reaction forces, and a little bit about viscoelastic structures.
And that's it. I'm Nicole.
I'm Jared, and
That was some biomechanics.